Okay, so on the exam, you will be given a question with at least 7 op-amps. Let's see if we got to one here. This has, I think, 6. And the question will have 2 parts. The first one is, which configuration is each one of them? Or which ones are inverting, which ones are non-inverting buffer? So buffer is part of non-inverting, but you need to identify which one is a buffer. Then comparator, summing, and difference amplifiers. So you're going to go, you need to necessarily, for example, look at A and know that this in principle inverts the signal because on the minus, but it's a specific kind of inverting. It's actually a summing amplifier, so I would put A here. And then I'm going to go look at B. B has a feedback, it's shorted, the output to the minus, that is a buffer. C has also a resistor as feedback and an input resistor, and the positive input is grounded, so it's an inverting amplifier. D is the inverting inputs is grounded, there is a feedback resistor, but the positive input, the non-inverting input, is hooked up to a power supply, in this case minus 1 volt. This means it's a non-inverting. Now E has no feedback resistor, so the output of E is connected to the input of another op-amp, but within this op-amp here there is no connection between input and output. The only configuration we have learned for this is a comparator. It's the first op-amp class. F has the same situation, so this is the output of F, goes to another op-amp, and the inputs come from other op-amps. It's also a comparator. It looks like I don't have any differencing amplifier, so I wouldn't answer this question or this particular item. Second question, second part of this question will be, what is the output voltages of each one of these? So I'm going to call this, to make it simpler, V. The output of A, for example, is VA, and then VB, VC, VD, VE, and VF. Now, the output of F is not the output of the circuit. The output of the circuit is possibly this one, VA. But if I start by trying to find VA, I realize that this is a function of VB, 2 volts, which is here, and then whatever is connected to here, which is minus 1 volt. So actually, I can even write what VB will be. VB will be, I'm sorry, VA. VA will be minus VB divided by 4 minus 2 divided by 2 and plus 1. This feedback resistor and this resistor the same value. The closed loop gain for an inverting amplifier is minus RF divided by RI. But here I know this input voltage, here I know this input voltage. Here I don't. So I still need to find VB, which is going to be the same as as VC, because this is a buffer or a voltage follower. VC will be VF times minus 3. So hopefully you see VF here, and it gets multiplied by minus 3 because of the C op-amp. And then VF will be either plus 15 or minus 15, depending on VE and VD. So really I need to know what VE is and what VD is. Both of them are independent. So VE gets 2 volts in from here, versus 0. So I can start the answer to this question by saying I know for sure VE equals minus 5 volts. I hope that's clear from comparators. So this is winning. So minus VCC goes to the output. And VD it's a non-inverting, which gets, you know how much? Oh, I know. Minus 1 volt from here. And it gets multiplied by 1 over 2 plus 1 by 1.5. So VD equals minus 1.5 volts. So now if I have minus 1.5 here, and if I have minus 5 here, 1.5 is larger than 5. And therefore the output of F is VF is 15 volts. Now that I know VF is 15, the problem is this VC wants to multiply 15 by 3, but it only has a 15 volt rail. So the original VC would be minus 45 volts. But really VC ends up being minus 15 because the op-amp cannot supply minus 45 volts on its own. We're considering ideal op-amps. And once I supply here with minus 15, the VB, even though it should have been the same as VC, it's only powered by plus minus 5. Therefore, it only goes to minus 5 volts. Again, this is a paper circuit to show that you understand the limits on rails, even for a buffer amplifier. So I know now VB is minus 5. Now I can tell VA with this, I can use this formula to tell what VA is. I apologize for capital and low capital here, but it's 1.25, right, 5 over 4, minus 1 plus 1. So it's really, actually I should have done this already. So it's 125, that's VA. 1.25 volts. This would be all the voltages on the outputs of op amps. And hopefully this is simple enough for you to follow without me writing all the equations.